and one of the co-founders of Snapdrum, and also been teaching on Maven for a very long period of time, teaching AI for engineers, but also non-technical product managers, founders, operators on how to sort of leverage AI into their day-to-day workflows. So that's like pretty much what I've been doing in the last, I would say, 2 to 3 years, like pretty much teaching a lot of folks AI. And one of the areas I'm super interested in is in context engineering, which is a subsection of AI engineering. So for today's session, the focus is going to be quick introduction to AI engineering, and we're going to understand like what is context engineering means and like how to create like a good context when it comes to building AI products. And also like how do agents get context, like especially when you're building multi-agent systems, and how do they get context, and like how do you sort of like look at that from different angles. So that's one of the areas. And also at the end, we'll have discussion around long horizon tasks, which are like AI agent tasks that runs for a long period of time, like multiple hours, like even more than a day. So when it comes to long horizon tasks, like how do you sort of like handle context? So which is like a very, I would say, nuanced area. A lot of like research is happening on this, and so I'll sort of bring about some sort of learning from industry for today's session. Right. So I guess like the first thing we need to understand, like what is AI engineering, right? So this the term sort of like get sort of like misinterpreted a lot, but generally if you are speaking about AI engineering, it is about like the practice of building production systems on top of foundational models, like any kind of AI model. Like if you use them to build software on top of that, that's pretty much called AI engineering. So it is not ML engineering, like which is like used to be training traditional models, which is obviously there's one part of that, but it's pretty much not the main focus. Like there are like folks who train foundational models that would necessarily be considered AI engineering. And then it is also not like just software engineering, because you're building these solutions on top of like probabilistic models. So because of that, you can't necessarily bring about like traditional like software engineering principles. There are a lot of things that we bring about, but also there are certain things you need to manage. Like for example, bringing in things like evals, etc. So you need to like make sure like you're building systems like for non-deterministic components. And then it is not prompt engineering simply because it's part of it. Obviously, that's where everything was started, but like it's sort of evolved beyond prompt engineering. So it is just one part of the equation, but it's not the entirety of AI engineering. And then the focus is like how do you build reliable software products with the use of these non-deterministic probabilistic components models. So that's the whole the focus of AI engineering, and you also like draw inspiration from lots of domains, especially software engineering, but also from general machine learning principles as well, to build a really good software. So that's what AI engineering means, and part of that is context engineering, and we're gonna like talk about that today. Um, so if you look at like the way that jobs are shifting, like in 2023, like pretty much focused on the prompt, like having like a really good prompt. How do you structure the prompt? So that sort of moved on to today, which is like how do you sort of like define the context? It's called context engineering, and there's like harness engineering. So you have like a bunch of like buzzwords here, but the idea here is like how do you sort of provide the right information to your AI model, whether it's like Claude models, OpenAI models, it doesn't matter. So to that model, how do you provide the right information? So that's what context engineering means, and there are a bunch of ways you can go about this, and we'll sort of like dive into that today. All right. So what is context engineering? So I think like as I sort of mentioned earlier, it is about like how do you sort of control what the AI models see, and sort of engineering that in a way that you get the best outcome. That is what context engineering means. So it is not just prompt engineering. So you'll have like a lot more information around that your model. So like we'll like look at a small example to understand what context engineering means. So this is like a really good, I would say, diagram provided by Anthropic on their blog post to compare like prompt engineering versus context engineering. Prompt engineering versus context engineering. So if you look at it on the left-hand side, you have general, the system prompt. I'll make this a bit bigger so that you can see. You have the system prompt, you have the user message, and you send that to a LLM. So this becomes the context window, and this becomes the prompt, sort of like the prompt engineering piece. So you like probably iterate on the system prompt to write like a really good prompt, but that's not the I would say nature of the AI product building these days, it is what you have on the right hand side. That's where you have like a lot of engineering needs coming in, because you need to like consider the types of documents you have. Like you have like the short-term memory, like you have documents, long-term memory, and you have like message history, you have tool calling, so which is like different kinds of services that your AI model can call like at runtime. So you have all of these like sort of like context that you can use, and out of that you need to pick the right information to be sent to the large language model, because like there's obviously two issues. Like I'll go into that in detail. Like in generally, you need to have that right information in the context without bloating that, but at the same time without sort of like distorting the information that you have in the context. So only then like you can have the right info, like the better outcome from the AI model, and then it's like you have this like the tool sort of like the loop where you have like depending on the feedback you get, you can have like really good context again. So that's pretty much it when it comes to context engineering. So the idea here is like, how do you sort of like define this curation step? So that's the main thing. Like, how do you like, with all this information out there, like how can you define the right information that goes to this context so that the AI model would have the right the context to take its next action. So that's the difference between prompt engineering and context engineering. And I'll show you in a bit like why it is important to sort of curate this context, because there's some issues like if you sort of like bloat this context. Um, right. So this is the point I want to make, right? So the context is like a finite resource. So you can't necessarily put everything. Obviously, you might have seen the context window, which is the amount of information that a large language model can consume in one go. It's pretty much defined by number of tokens, which is like you can sort of take it as like these like small pieces of information that the AI models can understand. So it could be text, it could be images and videos, but it's pretty much how we sort of measure the length of the size of the information that has been sent to the large language model. So there are two main issues with this. Like one is like context rot, the other one is attention budget. So the context rot is pretty much the more information that you're going to add to the context, the amount of the accuracy of like retrieval from that information is going to get reduced. So this has been shown by like actual research. Like when it goes beyond certain number of the length of the context increases, the probability of getting the right information reduces. So there are tests like needle in the haystack test that you can do to evaluate the accuracy of certain like sort of like solutions to figure out like how well the model or the system is capable of pulling the right information. So because of that, like it is not always good to add a lot of information. So even though the context of the large language model sort of enables you to add, let's say, 1 million tokens in the context, you shouldn't have that, because obviously it takes a bit of time to do the calculation, but at the same time it is not able to pull the right information out. So you should always do enough work prior to sending the information to the model so that you could have like obviously efficient calculation, but at the same time have the right sort of outcome. The other one is like attention budget. So if you look at like the attention mechanism, how the transformers work, which is the foundation architecture of like the current algorithms in large language models, using like a n squared algorithm. Like when it comes to attention, you need to like do calculation across like all the components to get the attention score calculated. So because of that, the more information you add to the context, it's going to take like the time it takes to do the calculation is going to get increased. So it's like associated with n squared, the time, the time complexity of the algorithm. So because of that, the more you add, it's going to get like time n squared. The n mean the length, the number of tokens. Like so it's always good to like reduce the number of tokens so that the time it takes to do the calculation for the attention, it's going to get reduced. So these are the two main things when it comes to like why you need to have context engineering, why you shouldn't like put lots of information in the context. So I think like I hope I made the case for like having context engineering, like why it's so important, and like you can sort of like dive into a bit deep. Like if you read the attention paper, you'll understand why context needs to be carefully curated. All right, so like if you want like keep this in mind, like I think like the general principle is like finding the smallest possible set of high signal tokens. So like so figuring out like out of all the information that you out there, like what sort of like what's the smallest sample set that you can provide to the large language models in a way that gives the enough information so like to make a decision. So you shouldn't like put everything, like you should like clean as much as possible, pick the right information, prioritize ruthlessly when you put information to the large language model. So that's what context engineering means. So it's pretty much like at it's an engineering call and it's a judgment call as well to figure out like what sort of information that needs to go in. So this is like the general engineering principle you need to follow when it comes to doing context engineering. All right. So let's dive into like what like really good context engineering means, right? So you have on the left hand side, so if you take like some sort of a system prompt, you have very specific system prompts. You have like, I'll make it a bit bigger. So you have you are a helpful assistant for Claude's bakery, etc., etc. You have like really detailed instructions. I mean, this will get the job done, but this is not generic enough. It's very too specific. And on the right hand side, you have something very vague. You have like, you are a bakery assistant, you should attempt to solve customers issue in a manner consistent. So this is like a example, so this is not what it looks like, but generally this is like the principle you should follow. You shouldn't like be too specific, you shouldn't be too vague. You should have something like this which is descriptive enough to get the work done, but at the same time you have generic instructions. So not like building something for a specific set of examples, you're building something to general solution. So because of that, like you really need to like go through a couple of iterations, but getting a prompt like this, context like this, where you have enough information, but at the same time you'll have generic guidelines so that you can like expand the solution for general scenarios, not for the ones that you've already seen. So I mean, I recommend reading this white paper from Anthropic on like effective context engineering. It's a really good read. So like pretty much most of the slide deck is created from that guideline, so which is quite interesting. All right, so when it comes to sort of like understanding the so the minimal viable set, like which is like what do you need to like put in the context, right? So if you look at tools, right? So tools are like the type of services like the that yeah so so the tools are pretty much what you can actually sort of tap into, like when a model is running, like an agent is running, what sort of things it can tap into, right? So it is the contract between the agent and like other services. It could be APIs, could be DB calls, like a bunch of things, right? So when it comes to the having the minimal viable set, so you have to make sure that things are like pretty much defined really well, right? So for example, like the tool is should be self-contained, and it should be like handling errors as much as possible, and obviously like figuring out like when you get a result from a tool, should I like send the entire data set back, or should I pick like a summary of it? So depending on the use case, there's always good to like check what comes out of a tool. And like if you look at like really well defined tools, you'll see these kind of like actions in place. Like it doesn't like necessarily send everything, and you have like a bunch of options in the tool to like filter information, and also obviously no overlapping functionality between tools. Like the tool should be self-contained, and it shouldn't have like shared sort of shared functionality across other tools. So you need to have like something that defines really well. Like general principle I sort of like follow is that human should be able to like define like for a given task what sort of tools that he needs to call to get the job done. If a human engineer can't decide like what sort of tools to call, like AI agent wouldn't be able to. So always like figure out like a given a set of tools and its descriptions, does this make sense for a human to like decide like what sort of tools to make sort of invoke to get something done. So if a human can do it, there's a high probability an agent can do it as well, as long as you sort of like write a good description, write like really good output message, etc. So if you define that, there's a high probability you'll get like a really good sort of context engineering setup. All right. So when it comes to like sort of like having I would say examples in the prompt that you're sending. So you might have heard like this like few shot prompting in the past, which is quite helpful, right? So but it's always good to like have examples that are uh, good enough that covers like 80-90% of the scenarios, but you shouldn't like putting all examples in there because that's going to like obviously sort of like make the context poisoned, I would say. So you should like pick examples that are descriptive and explain enough to like define the problem space, but you shouldn't necessarily put all of them. So you pick and choose the one that would give the best I would say the a spread of scenarios that the AI sort of like the model would face, and then you sort of like use them as examples within the prompt. So this is like one of the ways that you can sort of like definitely control like how the model works at the same time, sort of safeguarding it from like poisoning its context. Yeah. All right. So the next thing is understanding how agents get context. So we talked about agents. So agents are pretty much sort of like it's a pretty much a while loop. So these agents are connected to large language models, and it will sort of like when you're given a task, like if you ask something to do it, to figure out like what sort of actions it needs to take, and go ahead and sort of deliver that based on its available tools, and sort of runs in a loop until the task is finished. So how does these agents get context? So there are like few ways to look at this. So there's like this like preloaded and just in time context that you can get. So you have, especially if you look at RAG systems, that has like pre-inference, like preloaded. So where you have like before it sends to the large language model to process something, you actually like load some information from a vector database and populate the prompt that you send into the LLM with the right context. So this is one way of doing it. But then you have like just in time, right? So in the context, you would have the types of tools that you can access to, type of APIs that you can call to. You have a bunch of descriptions, but it's not populated with the right information. You only have this, I would say, instructions on how to um, do certain things, but not necessarily everything is there. So depending on the path that the agent takes, it will load the context from larger. Like for example, if you take skills in Claude Code, this is like one good example, right? So in skills, like you wouldn't necessarily load the entire skill to your system prompt or the context. It will only load the description of the skill when it is time to invoke that specific tool call or the skill. So it will like load the entire sort of context when it's needed. But until that, it will only have the description of that skill. So it knows, okay, I have like X, Y, and Z skills, and I know when to use them, but until the time comes, I wouldn't necessarily pull that context. So that's what it's called just in time. So when it time to call that specific skill, it will load that context, and that's going to save lots of context space, and also like will give you the ability to like run the agent quite lean across like multiple steps. So these are the two types of the context loading mechanisms when it comes to agents, and you'll see like some variations of this like when you look at like actual sort of deployment of agents. All right, so the next thing is about long horizon tasks. So you might have heard this word a lot, like which is like running agents for a very long period of time, like not just like few minutes, but like hours and hours. So when that happens, there's a high probability the context is getting large because you have like multiple agents running and they'll have like a lot of information coming in, and this is pretty much will go beyond the general sort of like the context window. So if you pick like any cloud model, like it's like they have like 128K context window. I mean, Gemini has like 1 million context window. Either way, like it's a context like a bounded thing. So because of that, like there's a high probability you'll hit the context window. So there's always needs a mechanism to control the context when it comes to long horizon tasks. So that's what we're going to talk about right now. So there are a bunch of ways that we follow to sort of like manage the context in like long horizon tasks. Like some of the ways are like compaction, you have structured nodes, you have sub agents, right? So some of the like I would say 80% of the mechanism that being used there can fall under like one of these mechanisms. So compaction, as the word says, you are sort of like summarizing the context when it hits the threshold, right? So for example, if it is very close to, let's say, Claude model 100, if it gets to 128K tokens, Claude has a skill that's going to like read the entire conversation, and it's going to pull out the relevant information and have that as the new context. So it forgets everything beforehand, but you have a new context, like a sort of like a context that has summarized the previous conversation. So that's going to like give us, the agent will use that to continue the conversation after it has sort of filled the context window. Now we have like a new context. So that's one way. And you have the structured nodes, pretty much is around like you might have seen if you use Claude Code, like it writes to a readme file. Like you'll have like different features that you build, a .md, you'll have like a readme file with the decisions that you make, the outcome, etc. So this is like how Claude sort of like remembers everything, and agents can follow the same structure. So whenever you need to like restart something, you can go and read the actual readme file and load that into the context, and that becomes the context that you can load in the future. And there's sub agents. So rather than running a single agent, you break down like sub agents, and each agent would have specific memory, and that agent can maintain like a longer run, because you have like multiple agents with like multiple contexts, and they'll have their own memory and they have their own context window, and now you can like run like multiple agents and have a broader context window access. So that's like another way of like handling that. This is quite important. Like if you're running like this multi-step process, like research tasks, like research and writing tasks, is quite interesting, because you can like actually isolate certain steps, and those like steps can be sub agents and they can have their own context. Right. So let's look at each, right? So I think like compaction, I think like you might have seen this on Claude Code. It automatically does this, but you can also manually control this as well. So generally, if you are sort of like building something from scratch, you might need to like borrow some inspiration from something which is already working. You can check what how Claude Code is doing this. But either way, the idea is like you need some sort of a prompt that's going to read the entire context and pull out the right information that is needed to sort of continue the process after the context window is reached. So the idea is that this is pretty much defined by the domain expertise, because like somebody with the domain expertise would understand like what sort of information to pull from the context to maintain like a really good long-term conversation. So if it's a software engineering project, yeah, the software engineer would be ideal. But if it's like a non-software engineering project, you need to bring an expert into the mix to define this prompt to do the compaction. So this is where I would say like the expertise comes into play. You can't necessarily blindly like vibe code something like this. You definitely need to understand what sort of goes into the logic of compaction, because this drives the next phase of the agent that sort of like use this output as its context. Um, and then the next part is like structured note taking. Obviously, you'll have pretty much things around like to-do list, like notes.md, like you have some sort of memory file that's get created in like readme, and you'll see like if you start building features using Claude Code, you have like a bunch of like readme files like this. This is pretty much a way of like a Claude Code sort of posing its steps and like saving certain information in your context. And this is pretty much what it says. It is actually saving the process and the decisions, and this is like another way of like maintaining context. And third point is like sub-agent architectures. So you're sort of like breaking the main task into like sub-agents, and each sub-agent could have like its own sort of like context, and you can have like a really good like long-term conversation with that agent, because the sub-agents would also maintain their own context. So this is like another way of thinking about it. So I think like if you like take away like from the entire conversation, it's about like finding the smaller set of high signal tokens that's maximize the likelihood of your desired outcomes. That's pretty much it, right? So the idea is like how do you like in this, because in this like vast amount of context like it's coming from the system prompt, different APIs, documents that are in the rack systems, you have all of that information. Like from that, how do you make sure that you provide the right information, the right signal to your agent, so that you can run whatever the AI solution that you want to run. So that's a pretty much, I would say, like the fundamental theme that you need to remember. So, and always remember like context is a finite sort of like a precious resource, and you shouldn't necessarily like every token that you put in needs to really fight for it to get there. Otherwise, like it's like the quality of your product will go down. So you have to be a bit thoughtful on that. So, and if you can like engineer that really well, your AI agents, like AI solutions, would like really like outshine compared to other sort of solutions. Also, like if you guys are interested in discovering this further, there are a couple of courses we run, one on AI engineering bootcamp, one on AI native PM certificate. Depending on your sort of background, you guys can check it out. And you can like scan them as well. There's like 35% discount on both the courses. Just reach out to me. Happy to sort of like arrange that as well. But thanks a lot for sticking around as well. Amazing. And yeah, see you guys in the next one.